Hey everybody, word problems, everybody's favorite. So we're looking today to make the best score possible in the GED math. And this also helps on other tests like the SAT and a few others. So we want to take functions to model word problems. Now people get scared, but if we can think through things systematically, if we can follow a process and take stock at what's in the question, we can start to see a relationship between the numbers. And we'll be able to come up with an equation. The hardest thing to do is to come up with the equation part. Once we set the equation, most of us can handle the algebra. So let's look at the kind of word problems you might see on the GED test. Now we're going to focus on quadratics. The quicker we can get our problem off the page of the textbook or the worksheet and onto our paper, the easier everything's going to be. Second, the next thing you need to do is find the guiding thing in the question. Is it a volume question, an area question? How about a revenue question, a distance question? And then, once you recognize that thing, think about what you already know about it. Alright, now let's look at a standard question that you may see on the test. Okay, let's say that a company sells 100 items at $12 a piece. So, they sold 100 items at $12 per item, per unit. Okay? So, you need to quickly learn to look at that and see that they would make $1,200. And I got the 12 and I just added the 200, the two zeros behind. Okay, but that's not what we need. I just want you to start doing in your mind as much math as you can. Just keep, the more you can do it, the more repetitive you can get, the better. Okay, so here we are selling 100 items for $12 per unit. Now, for each $2 increase, let's say that they're making a lot of money, and someone at the marketing table says, you know, I think we can get $2 more per unit. Okay? So let's write that down. So for every $2 increase, okay, so they said, well, we're going to go $2 higher. And then at the end of the week or the end of the month, they say, well, wait a minute, there's a relationship here. Now we're selling for $14 per unit, but we're only selling, for every $2 increase, we see 95 items sold. Okay? So here's the relationship. There was 100 items sold. Now there's only 95. Okay? And the other relationship is, well, we were asking 12 bucks, but now we're asking $2 more, which is going to be 14. So at 100 items, we could sell it for $12, and if we ask for $14, we're only going to sell 95 items. That is a standard test question that you will see on the test. Now, how to solve it. So I want to take revenue and explain that real quick. Okay? So revenue is your thing that we talked about earlier. We know that revenue equals, what do we say? Items sold times the cost. And in our example, we had sold 100 of something at $12 a piece. And then I introduced a change. And that change said, I'm going to go up $2 on the cost. So let's look at that for a minute. So we're going to go right up above here, sold at $12. Then I said we were going to go up $2. Okay? So we're going to have a $2 increase. Okay? That would be 14. So a $2 increase, but at the same time, we're going to have a 5 customer decrease. Okay? Now let's keep doing that. Let's keep looking at the relationship. We're going to add $2 more, and we're going to lose 5 more customers. Okay? And we'll do this one more time for good measure. We're going to go up $2 more, but I'm going to lose 2 more customers. Okay, so I could make a table like that, but it would get lengthy. And we don't always have time to make a graph like that. So we want to know how we can represent this change in an equation. Okay, so what we need to do is to generically come up with a way of how we can express this increase in price and drop in customer sales. Now, how do we do that? And what we need to do is, I want to know, as a business owner, what's going to make me the most money. What should I charge? And maybe we went down and used a table a while ago. So let's use a variable, and let's call it X. Now you can use P, A, B, C, it doesn't matter. And let's say that X is the number of times I raise the price. The number of times I raise the price. So if I raise the price one time, it's going to go up $2. If I raise the price 2 times, it's going to go 2 times 2 is 4. If I raise the price 3 times, it's going to go up 2, 4, $6. Okay? So let's look at this. Okay? Right here. For every time, that would be the equation. Here's the $12 we originally started with. We're adding $2. If we're adding $2 one time, then 2 times 1 is 2. And we just went over that, okay? Now, we need to look at this. We said for every time we go up $2, we're losing 5 customers, okay? So what it will be on this side. And let me write this in another color here so we'll know. Okay? So we got 100 customers and we're losing 5 depending on how many times we raise the price. Okay? So for every 100 customers, we have to subtract 5x, with x being the number of times I raise the price. Okay? Now we're going to get rid of this and we'll just put a dot here. And we have a quadratic expression. Alright, so this now becomes a function. This now becomes a function of revenue where x equals the number of times I raised the price. Now there's all kinds of things now that the question can ask you. It can ask you to graph it, okay? Now I hope that you see that this quadratic expression is a Pueblo, okay? And you can look at one of my other videos to see what a Pueblo is. So a Pueblo graph is going to look like this or this. So we've got revenue as a function of x, which is the number of price increases we have. 100 minus 5x times 12 plus 2x. There's a lot of different things I could do with this. I could use this quadratic formula and expand it out, okay, to solve roots. But I'm wanting you to see something here. Why don't I set this whole thing to equal 0? Okay? So let's see what that'll look like. 100 minus 5x times 12.2x equals 0. Okay? So let's do the first one. 100 minus 5x equals 0. Okay? We don't need the parentheses here. Sorry. All right. So if what I want to do is I want to bring, okay, you with me? Okay, and then we'll so we got x equals 20. Now, if I went too fast with that, you can go and look at one of my other videos to know how to solve that. Okay, so now we also got to do the 12 plus 2x equals 0. X equals negative 6. So now let's go over to a graph. All right, in the first example, we took 100 minus 5x. We set it to 0, and we came out with x equals 20. Right? All right, so let's plot that, okay? Remember, we're looking at the x-axis only, because we are looking for a parabola. Okay? So, got right there. Okay? And then we had 12 plus 2x, and we set it to 0. Okay? And we got x equals negative 6. Alright, so still on the x-axis, let's go back to 6. We know this is 0, and this is negative 10. So 2, 4, negative 6. Okay? Now, that's the only 2 points that we need. So now we need to find the halfway mark. Okay? So, this is a total of 20 and 6. So that would add up to 26. Okay? All right, we know that there are 26. So we're looking in a parabola. We know that the midway point is the vertex. Okay? So we need to find the halfway point between 26. And we know half of 26 is 13. So we have to count backwards 13. Well, that's 10. So let's go back just 3 more. And it would be 8. Oh, 7. That's 8. So right in here. So we know that the halfway mark, the vertex, is 7. Okay? So now, let's take this 7 and let's do something with it. Alright, now we have the number 7. So let's plug 7 into our variable x. Okay? Let's start out with 100 minus 5 times 7, which is 100 minus 35. Okay? Which would be 65. Okay? Now let's do this one. 12 plus 2 times 7 would be 12 plus 7 times 2 is 14. Okay? 12 plus 14 is 26. We would multiply 65 times 26 to get the answer. Also too, I want to say, now we know what the function x is, so we can take that x out and we can look for revenue as a function of 7. Alright guys, so let's wrap it up. So all we have done is we have modeled a function that the variable is changing, and we know that that's revenue is total sales times total price. I hope this helps.